Good afternoon, everyone. Welcome to our afternoon session. Especially welcome to Indu ma'am. Is one of our faculty, Dr. Dhananjay is going to introduce you now.
Thank you, ma'am.
Good afternoon, everyone. Good afternoon, ma'am.
Good afternoon.
Welcome to 12th session of the workshop where we will learn decision trees from the speaker of the session, Miss Indu. Miss Indu is currently pursuing her PhD at International Institute of Information Technology, Bangalore. Indu has done her BTech from Kerala University and MTech in Electrical Engineering from IIT Madras. She worked as senior research staff with Central Research Lab, which is the R&D division of Bharat Electronics Limited, which is popularly known as BEL, and contributed immensely for various defense R&D projects. She has published several research papers in international conferences and filed several patents. She is a recipient of R&D Excellence Award for her contributions in R&D project titled Imaging Software Development for X-ray Baggage Scanners. Her areas of interest are machine learning, image processing, deep learning, and geographic information systems. With this brief introduction, I'm handing over the session to Ms. Indu ma'am. Madam, it's over to you.
Yes, thank you. Thank you, Dhananjay, for that introduction. So I welcome you all for my session. So hope you had a quick lunch and resume back to the session. So I will try to make it as interesting as possible. So I will share my screen. Am I having the permission to share anything?
Yes, ma'am. Yes, ma'am.
Yeah.
Yes.
Okay. Yeah. So my screen is visible?
Yes, madam.
Yeah, so this side one panel is appearing. Yeah, okay, now I could minimize it. So, okay, it went. Is it visible still?
It is not visible now.
Okay, I think. Now is it visible?
Yes, madam, it is visible.
Yeah, okay. So today's session is on decision tree, especially on iris data set and data visualization, data preprocessing, and modeling, training, etc. So we will start with this iris data set, and first I will be showing you the data visualization part. So about the iris data set, it is a very simple data set which is used for machine learning problems. So it is a toy data set. It is already available in Python library itself. So I think morning session also you were introduced to iris data set. So you must be knowing some facts about it. So now just for the purpose of some general knowledge, the iris data set is also called a Fisher iris data set. So it is a multivariate data set introduced by British statistician, eugenist and biologist Ronald Fisher in his 1936 paper, The Use of Multiple Measurements in Taxonomic Problems. The data set is having 50 samples each of 3 species of iris flowers. So it is having a data of iris setosa, iris virginica, and iris versicolor. So these three flower in data information is contained in the data set. And what type of features are there in that? It is the length and width of the sepal and petals in centimeters. So these are the 3 variety of flowers: iris versicolor, iris setosa, and iris virginica. And this is the sepal, and this is the petal. So the measurement of length and width of these things are gathered as the data set. So now the first step in Python, so I think since 2-3 days, you must be seeing various sessions in which they are talking about Python language and how you work with it. So I am very comfortable with Jupyter Notebook. So that's why I'm showing with Jupyter Notebook. And the main advantage of Jupyter Notebook is that you can run the Python commands cell by cell. So it will be easy to debug, like any error happens, you will understand in which portion of the code is having error. So you can try to fix it there, and all that type of some advantages it is having. So till time you are developing the code, it will be very useful when we work with Jupyter Notebook. So first step is to import different libraries. So Python is having numerous libraries which are of which are very good and well known, and it is used for all the programming purposes. So that is very used ones are called NumPy, Pandas, Seaborn, and Matplotlib, all these things. So I am importing those libraries for this demo. So first, this NumPy, I think you must be knowing. So it is a library which contains lot of information regarding means a lot of functionalities regarding numerical data, like especially the matrix data, matrix of different arrays, like multi-dimensional arrays. All these things can be handled very easily with NumPy. And even it contains many statistics related functionalities also. And it has linear algebra functions like eigenvalue, eigenvector, covariance matrix. All these type of many things are there in NumPy. So it is a very useful library. So at the beginning itself, everybody will do is to import that. And then Pandas is a library which can handle data structures, kind of, especially the tabular data. And it has so many functions. It can read Excel files, CSV files, and all these type can be done with Pandas. Then Seaborn is a library which is mainly used for plotting, like all the data visualization and the EDA, exploratory data analysis kind of things can be done with Seaborn. And then coming to Matplotlib, so Matplotlib is also another well-known plotting library. And now, as I mentioned, it contains many data sets, like which is generally called toy data sets. So it is mainly used for the purpose of learning and understanding the exploratory data analysis and all these things. So one of them is IRIS data set. Then there is other data set like diabetes data set, then breast cancer data set, like that. So many are there. Even that many are like these things are classification related, and there are regression data sets also. Like you might have seen that Boston house pricing. So that is a regression data set. So it contains all these data sets. So and I am also importing this preprocessing also, and Matplotlib inline. So this is the first set of import functions I am using. Yeah, sometimes like this, some warnings will come. Is it clearly legibly visible? Can anybody?
Yes, madam.
Yes, ma'am.
Yeah, okay. So so this mainly occurs because of some I might have installed the Python more than a year back. So now new packages are coming. So because the update is not done. So that's why. So these things we can ignore, not a problem. So now there is a help function available. So usually you can even go to Google and search for each function and get the idea, like how what it is, the function, what input it takes, what it gives out, and all these things. But there is a help function which is available in this itself. So in this case, if I type help np.mean, so this is this, if I run, it will display the numpy function mean. So what it does, what it takes, what output it gives. And if you come down, there will be see that it returns what array, and all these things will be given, and there will be some examples also given. So this will be very handy, and it will be useful to quickly learn these things. So this is very useful thing. And instead of that, if you just if you don't put here like this, you will get an interactive window. Here you have to type and search like that. So both things we can try. So if I don't want to search, I can just type quit and I will come out of it. Now, as I mentioned, IRIS data set is already available in Scikit-learn. So I am just loading the data set here. So that command is load IRIS. So this is already there. So I am just loading it. And now this IRIS, this variable contains the data information. So this is this is the target. So this is the classes in the IRIS data set. So it is given as 0, 1, and 2. So actually, we have seen there are 3 types of flowers: Setosa, versicolor, and virginica. So in place of them, it is given as 0, 1, and 2. So now, if you want that entire variable, like I loaded the data set data, and this is the IRIS, what information it has, you can see. So this is the information which is coming to the variable IRIS. So this is having the data. So it is given as a numpy array. So 1 second. Yeah. So this is an numpy array, and this is the target is given. Then the name of the columns like Setosa, versicolor, virginica, and then the statistical information is given in that. And even some more information is also given, like how I mentioned in the beginning. This data set is developed by Sir R.A. Fisher, and that paper name, all these things are mentioned here. And this actually, when we install Python, this gets in saved in the file. So this is available in sklearn dataset data. So here it is saved as a CSV file. So that we can get from this one itself. If there are other data sets which is available, like in Excel format or in CSV file, that we can save in our like local folders, and then we can give the path correctly and read the data. I think some noise is coming. Somebody's mic is on.
Yeah, 1 minute back. Oh, just a minute back.
Yeah.
It's okay.
Yeah. Shall I continue?
Yes, ma'am. Yes, ma'am.
Okay. So now we can see what all features are there, and what are the target names, feature names and target names. We can print and see. So that is it is having 4 features or attributes. So sepal length, sepal sepal width, the petal length and petal width, and 3 targets, Setosa, versicolor and virginica. So now I'm converting the whatever variables are there to a data frame. So I am converting it to a Pandas data frame. So it will be easy for doing all these data visualization, plotting and all that. So that is why I'm converting it to a data frame. So that is a simple command, PD data frame, and I am giving the data and data as iris data and target, and np.c. This command is mainly for doing a column wise, like it will place these columns together, like iris data is having 4 columns and iris target is having a single column. So all these things are kept as a single table now, and it is saved to a variable called iris_df. And I'm saving one more extra copy of that in iris_df_save, because while doing the data visualization part, some type of manipulations we may do on the data. So original data may get tampered. That's why I'm keeping a copy of that. So now this is all Pandas. Since I converted to data frame, now all Pandas commands I can run with this data frame. So this is a Pandas command to get the information about the data frame, iris_df dot info. So now it will show all these information, like these 4 columns or 4 features are there, and that is sepal length, sepal width, petal length and petal width. All are actually saved as plot 64, and target is species, and it is saved as again plot 64, and its memory usage is 6 KB. So since this is a small toy data sets, even though it is saved as plot 64, it is not a big problem for us. But if it is a actual data set, like which we generally get, may have many columns, like sometimes hundreds of attributes, like 500 attributes, or even it may contain, like this is having only 150 samples. So sometimes it may be like lakhs of samples. So in that case, we cannot afford, if it is not required to be in plot 64, and if it is in in plot 64, it is occupying a lot of memory, and it may give problems later on when we start processing. So in that case, memory usage may be in MBs, like 100 MB space it may be needing. So when we start processing again and again, memory usage will increase and it will immediately give errors. So that's why in that case, we should actually change the data type. In this case also, we need not have float 64. We can have for these things, float, sepal length, these 4 features also can be just float 32. And this species, which is a also, which is actually having only 3 values, 0, 1 and 2. It need not be float. It can be unsigned integer. So that can be changed to that data type. So that I am showing with that species column. So I am changing that species column to unsigned integer. So that is what you can see here. So it is a simple command. So I am just getting the that particular column, like by using this dot. So iris_df dot species, and then I get that particular column, species column, from the data frame, and then I use this command dot as type to change it to unsigned integer, and I mentioned the data type whichever I want. So here I am using unsigned int. If I want to change it to something else, like float 32 or something, we can mention here and we can change it. So that is what is done here, and especially because I'm going to do the data visualization part, I'm changing and I'm putting all these 0, 1, 2, 3 also with their category names like Setosa, Versicolor, and Virginica. I'm not just putting it with 0, 1, 2, 3 because it will be more, we will be, when we see the plots and all these diagrams, it will be easy for us to have better understanding when instead of 0, 1, 2, 3, if we see the actual name of the class. So that's why I am doing that. When you do the regular kind of program for machine learning model development and all, you need not do that this step. So yeah. So that is now it is converted. So now we can again see the values. So these are the columns, and this is the info. So now if you see the data frame info, you can see that the last one. So here this has changed to object type. So earlier it was, see here it is floating point 64. So instead that now it has changed to object. So now this will be easy for us to use it in the displaying part. So now this is another command which is used in Pandas. So it is called head. So same thing, it is available like tail also. So head means it will display the first 5 rows of the data frame like that. So this is showing the first 5 samples from the data frame. So this is another command which is used with Pandas data frame, which is called describe. So it will give you the statistical information about the data set. So you can see here it is giving mean, standard deviation. Then it is showing the quartile, like minimum, first quartile, second quartile, third quartile, maximum. All this information you can get using this describe function. So, so now we are going to data visualization part. So this is the first part. So like how somebody told that a picture is worth 1,000 words, like that. So this is who is the told by whom, we don't know, because many sources say many different names, but this is very correct in this machine learning point of view, because we will data set means you will have only information like this. You will have several columns and some, if it is a classification kind of a data set, you will know what all classes are there. That is the information you are having. So it is all numbers. You will be able to see the numbers. You can see how big it is, small it is, but you will not know what it is representing or how it is like that. So those type of things we will have a better idea. We will get a better perception of the data when we do the data visualization. In Python, we call it exploratory data analysis. So we will explore the data to understand it better. So these are the main data visualization libraries: Matplotlib, Seaborn, Bocage, Altair, Plotly, ggplot, Geoplotlib. So generally, the most used plotting libraries are Matplotlib and Seaborn. And Pandas also is having some plotting function. So those things are also very easily and quickly used. And then plotly commands also you can see many cases. Then this geoplot-lib is especially for geographical data or satellite data and all, which will have many spectral bands and all that. So it will be a little bit different type of, and even spatial resolution also will be different. So that is a different thing. So which is handled with this type of different library. And so first we will see the line plot for the iris data set. So line plot is a very simple plot. So I think whoever might have worked with MATLAB, they will know that it is very, Python also is very much like similar to MATLAB. So this line plots are very common in MATLAB. Like if you give a plot command, it will show the line plot type of thing. So same thing is there in Python also. So these commands, whichever I am showing, like all these data visualization tools, so it is available with the Matplotlib also and Seaborn also. So it is up to your comfort. You can choose anyone. Generally, Seaborn gives a very beautiful, very nice decorative plot like that. So many times some people use Seaborn more frequently. So this line plot can be used for like if you have two variables, like in this case like sepal length and sepal width, or how sepal length varies. So across the data set, like 150 data samples are there, across 150 samples, how the sepal length, sepal width, all these things varies. You can see and understand very nicely using line plot. And another thing is that like if you handle, if you know time series data is always having on x-axis time as the reference. So like for example, population data or the stock market data, or like weather data across some 10 years, all these things can be very nicely represented using line plot. So you will see how the things are varying across some years of time frame, how it has changed like that. So line plots are the simplest and very useful also. So this is the command SNS. SNS means it is Seaborn and dot line plot. And you have to mention the which. So I am not using this species category, like it is a object category. So that classes of the target or the class it is. I am not using that. Apart from that, all other four attributes of the data set I am plotting. So if you just type in the help SNS dot line plot, you will see it will have lot many options to put inside in this bracket to plot. So everything we need not use. So whatever is very essential and required for our case, we can use. So this markers are not necessary that you use. So if I make it false, it will plot it without markers. So like this it will come. And this palette you can always change. So as you change it, you will get different colors like that it is. So one more is called rocket. So if I change it like this, so a color will change. So there is no other differences there. And many other options are there, like even you can customize how these plots, which one should appear in which color, and all that thing you can do with this. So you can see the variation, how it is changing like that. So this petal, yeah, this second one, petal length is like you can for many classes like petal length and petal width, you can see like once the 50 is crossed, there is a change, and for the next 100 also there is a change like that. So those things, as the category change, class change, the values also change. So those type of features are very good. But whereas in this third, this this one is actually it is the sepal width. Yeah, sepal width, you see, you can see it is almost going like without much variation. Variation is there within, but not a very big variation within the range, a little bit here there like that. If it is mean of this is 3, means it may be 3.6 or 3.8 to 2 point, that kind of a small variation only is there. But in these cases, it is showing a slightly notable variation, which you can, which really will be useful for our modeling purpose. So now we'll see the bar plot. So this bar plot is generally it is useful for the categorical data. So categorical data means it is not numeric data. It is the other, like in this case, the class. It is a categorical data, or maybe something like one column was there, gender, male and female. So those type of things are called categorical data. For those things, we can very well display using a bar plot. So I am counting the values in the species of different categories, and by using this command value underscore counts, and I'm using the counts and the index of the counts and plotting as a bar plot. So the one peculiarity is what is the height or the length of the bar plot will be equivalent. It will be equivalent of the data present in the data set. Like in this case, all are 50. So you can see it is all equal height it is having. Suppose there are cases like this IRIS data set is a very nice data set. It is not having any problems as such, which is generally faced with the ML data set. So many times it happens that it will have lot of imbalance will be there. Like in this case, all are 50, 50, 50, it is all good. But other cases, it will be like one set, one class will be 100 and other will be 10. So those type of information can be very easily perceivable from this type of a bar plot. And you can plot even it in the horizontal direction also, like whichever way you want, you can plot. And as I mentioned in the case of line plot, this functionality also will have many optional kind of options inside for calling. So you can even mention this is all, these colors are taken by itself. So instead of that, I can mention the color. I can mention the size of the figure, like many things is possible with this plot. So that is, yeah, in this case, you can see I changed the colors, but minimal is required to plot is this much only to get the plot. Yeah, now coming to pie chart. Pie chart is something which we have seen many times, maybe in case of all this, what is that, financial data and all that. So that is also available in, so this is from a Matplotlib function. So it is again, it is plotting the same thing, the contribution of each class in the data set. So yeah, so this is a very balanced data set with 33.3% of each class. And there is a command called explode. So it is I mentioned as 0.0 and 0.1. So it is showing it like this. So I can mention it again, 0 means it will not have that division of this one. So this is, and colors also we can mention. So in this blue, green and red, instead some other color we can give. And we can give this command to annotate on the figure, like it is writing it, what is the percentage and all. So that is also possible with this figure. So it is generally used, this is all used in case of exploratory data analysis, EDA. So you want to show, if suppose this is a balance case, the imbalance is there. So you will show that the imbalanced classes or minority classes only very small, like 3% only is there, like that. So those type of things are possible with the pie chart. So it is especially for giving a very catchy view of the data contribution, class contribution to the data set. Now this is the very, very important plot, which is called scatter plot. So scatter plot is also like, it is also something similar to line plot, but you can generally, you can show the variation between two categories or something like that with scatter plot. In this case, I am showing with how the sepal length and sepal width, all these with the sepal length and sepal width, all the three type of classes, Setosa, versicolor and Virginica data points are scattered across the XY plane like that. So this is a very useful plot. And what is different in this scatter plot is that we are not drawing the line, it will be represented using points. So instead of points, we can choose like small circles or triangles, any other thing can be chosen. So this is how it appears. So from this itself, you can see that if we use sepal width and sepal length itself, we can very easily separate. It is linearly, this Setosa, red color is Setosa. Setosa is linearly separable from the other two classes. So that is, if you put a line here, it is linearly separable. So it is very well, it can be perceived from this scatter plot itself. But in this case, this green and blue dots are not linearly separable. They are mixed in this case. So that also can be clearly seen. So the same way, we can make the plot for other data, like other features also. This instead of sepal length and sepal width, petal length and petal width, or sepal length and petal width, all these combination can be tried. But the scatter plot is a very important plot. It is very, very commonly used. Especially it gives an idea about the how the classes are scattered in the if it is a very high dimensional data, like if you have a something like 100 dimensional data, if you have, generally what is done is we use some dimensionality reduction techniques like PCA or something like similar to PCA, or one more is TSNE. So we use that and bring it to a two-dimensional space, and then we see how the data appears. So with that, we will get an idea about how well we will be able to classify the data like that. So this is a very important plot, which is called scatter plot, and very much used. So now coming to box plot. So box plot or box and whisker plot shows the distribution of quantitative data in a way that facilitates comparison between variables or across levels of a categorical variable. The box shows quartiles of the data set, while the whiskers extend to show the rest of the distribution, except for the points that are determined to be outliers using a method that is a function of the interquartile range. So box plot is actually using some statistical data for plotting it. So So in statistics, quartile is a type of quantile which divides the number of data points into 4 parts or quarters. So like that, even quartile is there, decile is there. So it will change, divide the data into 10 parts. So quartile is dividing it into 4 parts. That quartiles are used for plotting the box plot. And for getting the quartiles, we have to order the data from the smallest to largest. So generally we order from smallest to largest and find the midpoint of the data, or the 50% of the data, that is the median. So similarly, we have to find the first quartile, which is the 25% point. So below that point, 25% of the data will be there. And there is another point. So 25% point is called a Q1 or first quartile. And the second quartile is the median, which is the 50% point. Then there is a third quartile, which is the 75% point. So 75% of the data will be below the point. So this is a very good representation. So this, you can see a Gaussian distribution, and this here, this the box plot for that. So this is the midpoint. So this is the median of that, corresponding to that median. And this is the 25% point. This is the first quartile, and this is 75% point. So this is the third quartile. So this Q3 minus Q1 is called the interquartile range. And the minimum point and maximum should be at these points, like Q1 minus 1.5 times interquartile range should be the minimum, and Q3 plus 1.5 times IQR, interquartile range, should be the maximum. So this is how the box plot should be. So this is also useful in getting the outliers. So something which is beyond these points. So this has to be minimum, and this has to be statistically for the data. This has to be minimum, and this has to be maximum. So beyond this range, if data is coming, that is called a outlier, and it can be it is maybe because of the noisy kind of data capture, or manually entering some data, mistakes happen, and that kind of outliers can occur. So that is even box plot can show the presence of outliers in the data. So now we'll see how the box plot looks. So this is how the box plot looks. So this is again Setosa, versicolor, and virginica. So you can see this is how this is the median. This line you can see in the middle. This is the median. This is the first quartile. This is the third quartile. And this has to be the minimum, and this has to be the maximum for this range of data, this type of data. So this dot you can see, this is the outlier. This represents the presence of outliers. So you can take this minimum from the Q1 minus 1.5 IQR as has to be the minimum, and we can even exclude the, or maybe eliminate the data which is beyond that range, as it is the outlier, like that. So same here, you can see here also outlier is there. But one thing which we can see very clearly, that the Setosa is very nicely separable from the other two categories. Here these two are little bit coming in the same range, and that even this scatter plot we saw. So that is little closely coming, and division of that into two separate categories is little bit problematic, but this is very nicely separable. So, and even some more things which is understandable from this one is that you can see the median is lying here like that, and this line you can see the these things are not of equal length. So all these things also shows that it is not a proper distribution. It is a skewed distribution like that. That also you can make out from this kind of a plot. So here also you can see outliers are there. Yeah, so the same thing. So this is the sepal width. So when you use sepal width, again these three things becomes more like all of them are not separable kind of thing you can see. So it is all coming in some kind of some portion of the data is mixing like that. So this is another plot called violin plot. So violin plot is very much similar to this box plot. So we can see the similarity. So this is the median in case of box plot, and this dot here, this is the median in case of violin plot. So this is the first quartile here. So this is the first quartile. This is the third quartile. So in this case, this is the third quartile. So this is the Q1 minus 1.5 times IQR. So this is IQR in the quartile range. So this is the minimum point, same like box plot, and this is the maximum point. And this is the outliers like that. So one advantage of violin plot is that violin plot is a combination. It is a combination of box plot and kernel density distribution. So you can see the kernel density distribution, and you will be able to understand many things from that, like it is a proper standard normal kind of distribution, or it is a multi-model distribution, or what is the type of, or it is a skewed distribution. All this kind of information you can get from the by seeing violin plot. That is a extra advantage compared to box plot. Even in box plot we can make out, but this is without any applying any thought itself, because it is appearing, the kernel density distribution is also plotted. We can make out that. Yeah, so this you can see it is a proper Gaussian distribution, but these things are not like that. But as such, it is very much similar to a box plot. So these dots are the median. This is the first quartile, third quartile. All these things can be seen. Yeah, so some things we can see there are it is like multi-model distribution. Yeah, so now histogram. So it is, histogram is a plot which shows the frequency of occurrence of the data like that. So in generally, histogram is plotted like in x-axis you will have bins. So like 1 to 10, one bin, 10 to 20, another bin, 20 to 30, another bin. Like that you will divide it into different bins, and you will count the data, how many number of samples are, how many samples are falling into first bin, how many samples are in the second bin, how many samples are in third bin, like that. So histogram is plotted like that. So this histogram function is there, as I mentioned earlier, in both Seaborn also, and even in Matplotlib also. I am using the dist plot command from the Seaborn. So advantage is here again. Advantage is that it shows the histogram and also the distribution kernel density plot also. So that is one advantage of using dist plot. So it is a simple command. I just selected one feature, like one attribute from the data set, and I am giving the dist plot command. So like I mentioned earlier, there are so many things are possible with this. You can change the color. You can opt for only kernel. You can make the histogram. You don't want to see the histogram. You can, that is possible. You can only see kernel density plot, or only see histogram, and colors you can change. All that type of good customization is possible with this command. So this is, so yeah, see in this case I am making hist is equal to false. So it is not coming. And color I change to black. And there is another called rug plot. So it will show the how the distribution is like that. So it is, suppose if it is it all appears here between 2.5 and 3.5 is the entire data, means here it will have lot many sticks will be there, and the other places it will be. Here it is almost like same way it is going. That's why it is looking like this. Yeah, so this is now we are seeing the pair plot. So pair plot is something which is very useful. It is like in one shot you can see so many things like that. So it is all the kind of combinations. It will show you the variation of data. So it takes a little bit of time compared to yeah. So you see now it shows the this case also it shows the scatter plot and the kernel distribution. So in x-axis also all the 4 attributes are there: sepal length, sepal width, petal length, petal width. And y-axis also same thing: petal length, petal width, petal length, sepal width, and sepal length. So it is if you want to see the variation of petal width and sepal length, you can see here. And same thing, petal length and sepal length, you can see here. Like that, in one shot, you can see all the things together like that, how the distribution of sepal length is there. And then you can see for the other features also, how the scatter plot is there, how the distribution is there, all these things. So this is done so that like in one command you can see the entire, suppose so many, this case it is only 4 features we have, so that's why it is able to show little bigger graphs. So suppose if it is having more features, it will become very tiny graphs, and it will fill the page like that. So many small graphs will appear like that. But you can see the variation in one stretch like that. So now correlation heat map, this is a very important thing. So this is like a very useful thing. So what is generally like I mentioned, all these data sets which is used in ML have many attributes, many features. Like sometimes I have seen some data sets with 500, above 500 columns. Some data sets may have 150 columns like that. So those many data attributes will be there. So we don't know all attributes are useful for us, or whether it is useful for making our model like that. So that thing we have to see using this correlation heat map. So correlation means how the data is varying. So if in this case if I take sepal length and sepal width, so both are very similar. One is changing, the other is changing. So it is very linear relationship is between them. So maybe it is like sepal length. If I multiply it with 1.1, I will get petal length, or so those type of very close relationship is there. When one is varying, the other one also will vary. And correlation can be positive correlation, or it can be negative correlation. Positive means one increases, other one also increase. Negative means one increase, the other decrease. But there is it's a very close match between the features like that. So those type of features are there, means it is not adding any extra information to our model. And the disadvantage is that when we add many, like 100 features, 150 features we are adding, but it is not giving any information. It makes the model very complex. And if the model is very complex or highly complex model, means it may not be it is not a good model. Means it will not classify or properly when we give a test data, or maybe unknown data, it may not be able to classify properly. That disadvantage comes. So this correlation is a thing which is very important and which we can make use of it and eliminate. We can do some dimensionality reduction and eliminate some columns. So this is the, so first there is a command for finding the correlation. So we can use this dot core. This command is used for finding the correlation. And then I can, this is the heat map plot command, SNS.heatmap. I can give the correlation. So it will give a correlation matrix and we can plot it. It range from -1 to 1. And you can see here, so sepal, these diagonal elements are the correlation between sepal length and its by sepal length and sepal length itself. So all these things are one. So this you need not see. Instead, you can see the other point entry. So this sepal length to second one is sepal width is minus 0.12. So they are not correlated. But you see, sepal length and petal length, they are correlated 0.87 and 0.82. And to output, it is correlated 0.78. So there are even these features you can see, they are also very highly correlated. 0.96 and 1. No, yeah, so these type of things will cause problem when we make the model. So that can be eliminated after seeing the correlation matrix. So if you need not plot the entire thing because it caused some kind of confusion. This because it is this is a symmetric matrix. So you can see these entries are reoccurring at the off diagonal elements. So you need not see the entire matrix. You can avoid all these elements and only the upper triangular portion we can see. So that is what is done here. I am taking the upper triangular matrix of that. So instead of 4 bit, I can plot upper. And you can see that now those ones and all I need not worry about. I can see the other things. So you can see how the correlation is there between the this one. So there is a inference. So sepal length is highly correlated with petal length and petal width. So petal length and petal width also is highly correlated. And output species is positively correlated with sepal length, petal length, and petal width. So always output should be correlated with the features, but between the features, between the attributes, correlation should be minimal, because if correlation is there means it is not adding any extra value to it. So that we have to be very careful. And you can see this is using a color bar. So from the color bar, you can see it is negative to -1 to +1, it is varying. So -1 is given blue shades and after 0, it is going to plus positive region, it is shading in red. So as per the value, so as the value gets towards 1, so it becomes darker and it becomes more like you can see it became red like that. So that is how you have to read from the correlation matrix. And one more thing, I am keeping the annotate also. See, annotate is true. So that is why it is writing these values here. So that is that makes the reading or understanding process very easy. Yeah. So now we will go to the move to the data pre-processing part. So before that, I wanted to ask anybody is having any queries regarding the data visualization part. Then we'll quickly see 1 or 2 things. Otherwise, we'll move on to data pre-processing part.
Good afternoon, ma'am.
Yeah. Good afternoon.
Ma'am, actually, I have one doubt.
Yes, yes.
In correlation matrix, if the variables are strongly correlated,
Yes.
then we can drop one variables from the data set.
Yes, we can drop. Yes, we can drop the. Suppose in this case, as I mentioned, sepal length is correlated with petal length and petal width. So in this case, you can drop one of them because it is not giving any extra information and it is only making the model complex. So you can drop. And yeah.
From bar, sir, ma'am, just share the screen. The correlation matrix.
Yeah.
Ma'am, from the bar, how could you know the values of variables? That which variables are strongly correlated, which variables are negatively correlated? How could you know from?
Yeah, you can see here. See, this is bar. You can see it is varying from -1 to +1. Can you see that it is a bar is given the what is that numbering like that -0.8. Actually, it is starting from 1. -1, -0.8, -0.4, 0, 0.4 and 0.8 like that. So these blue shades are negative side and the red shades are positive side. And on top of that, we are, so I told, like I mentioned, like this not one, this one is there, and not is equal to true. So when I make and not is equal to true, it will write all the correlation values in the respective boxes, like sepal length to sepal width, how much correlation is there. You can read it from here. Like you can take, this is the one sepal length. This horizontally, this is the sepal length, and vertically you can see its correlation with petal length means you have to go like this and see 0.87. Can you see?
If it is means I'll keep between sepal length and sepal width. Only one feature means I can only keep sepal length.
Yeah, you can do that. It is possible. It is. It has to be done like that. You must drop the other highly correlated feature.
And again, ma'am, its value is -0.43. So the value is 0.43. That means it is negatively correlated. We cannot drop the feature.
Yeah, actually, it is the correlation value is also not very high. It is only 0.43, -0.43. So you need not worry about it. But if it is -0.85, then you should drop it. Because again, it is negatively correlated, but it is very high correlation. So you should not keep it.
And another, ma'am, if it is 0.96, also we can drop the feature. 0.96 or 0.95.
Yes.
Okay, that means, ma'am, as the bar lies between -0.8 to 0.8, then the values which are close to plus or -1, those features will be dropped from the dataset.
Yes, yeah. Yes, you are right.
Okay. Another thing, ma'am, is what is the significance of data visualization plot? That means what information we are getting from the visualization plot?
Which plot?
Scatter plot, ma'am.
Yeah, scatter plot. Yeah, so scatter plot, see, especially this is actually, you can see this red one, you can see that it is setosa. That is one class. And you can make out that setosa with these two features itself, sepal width and sepal length, it is separable. You can even make a model, ML model, machine learning model with these two features alone also, you will get a model which can separate the setosa from the other two classes. Like those type of information. Suppose if all these things are mixed together, then you can make out that all the classes are very much mixed and you won't be able to separate it that easily, or you can't what is that, expect a very high accuracy. Those type of understanding you will get from this. So how far you will be able to get a good model or high accuracy or not, all these things you can make out from that. And it is possible that if suppose you have a very high dimensional data, you can use PCA or TSNE kind of things and bring it back to 2-dimension, and then you can visualize using scatter plot.
Ma'am, so is scatter plot describe any relationship between two features?
Yes, it is showing the relation between the two features. Only thing it will not be plotting through lines. It will be just giving us the scattered points.
Ma'am, from this diagram, which information we are getting here? That means the data points are just scattered. Then what type of information we are getting from?
No, not like that. You see, one thing, I don't know, I will not be able to, anything I can write on this screen? Is it possible? Like any pointer or something is there? You can see my mouse pointer?
Yes, ma'am. Yes, ma'am.
Yeah, so if you use it, clearly it shows that if you use these two features, sepal length and sepal width, and if you can make a linear a classifier, like a line, if you draw like this, and that equation of the line, if you get, it will very well classify this setosa from these two other classes. That can be make out from that we can understand from the scatter plot. Suppose there are some other scatter plots which will be very complicated. You can see all the classes will be mixed together. So there you will understand that it is not very easy to what is that extract or classify the feature using the features like that. Those type of information you will get.
Ma'am, suppose length increases, then cepal width increases. This type of relation, whether we are getting from this scatter plot?
Not like in whatever existing relation, like from the data set, whatever relation is there, that we will get. It is not like if it increases, maybe that is how the classifier works. No, if it changes also, like if it increase or decrease also, that line here, if I draw a line, it will be able to classify the sepal. See, these red points can occur at any other location also, like it can come here. But even then, my classifier is like this line between these two, it will be able to classify. So those type of information you can get.
Ma'am, another thing is while plotting the correlation matrix,
Yeah.
all the values are located at the edges of the matrix, not at the center of the matrix. Why is this thing happening in Jupyter?
Where it is, I didn't understand that.
Ma'am, actually what happens, just see the values, ma'am, minus 0.12, 0.87, all these values are written in the center of the box. Okay, but while I am writing the code, then all the values are written above the lines. It is
Okay.
automatically written above the lines.
Okay. Maybe you will have to do some setting like this. Here you can see no axis, some setting I am giving. Axis set y limit 5,0 like that. I think you will have to put some limit for the axis or something like that. It is just a setting, this one. It is nothing related to that. Like I told you, I mentioned like so many options are there. So some of the things, like if you set it like axis limit or something like that, you will be able to get it properly. So shall we continue then? Ma'am?
Yes, ma'am.
Yeah, okay.
Now.
So
Yes, tell me, ma'am. Tell me. I'm Rupa.
yeah, okay. So we'll continue then.
Yeah.
Okay.
Yeah, you want 1 or 2 minutes break for you for you are talking continuously. If you want 1 or 2 minutes break, you please.
What is the ending time, like 4:30 or
4:30.
yeah.
4:30 is this. If you want extended 5 minutes like that.
Excuse me, ma'am.
Then no problem, we'll continue. Otherwise, I think I won't be able to finish it.
And because we started late, no? If
Yeah,
we want to take up to till another 15 minutes, 4:45 like that, no issue for us.
Okay.
But
Ma'am,
they
can I
do-
please ask a question?
Yeah, sure.
Yeah, ma'am, I've also written the question in chat box. I was just when you were explaining the correlation, and you were saying that those who are highly correlated features could be dropped out from the data set. Ma'am, is this what we call as data extraction or feature extraction or feature reduction?
Yeah, that is it is called feature reduction. There are other techniques also, but this correlation is one of the techniques which is used for feature reduction like that. You can use many real data set. You will see there will be at least 10 columns out of 100 columns. 10 may be highly correlated. So those type of columns you can see from the correlation value, and then you can drop those columns, so that you can do that is and that
Yes,
is
ma'am, there's one concept which is called as principal component analysis.
actually I will be covering that. You can wait for some time. I'll be covering PCA also, so you will be able to get
Thank you so much.
yeah.
Thank you so much, ma'am.
Yeah, so I will continue now. Otherwise, I think I may not be able to finish it. So now data pre-processing is a second topic. So in data pre-processing, the steps involved are again importing the libraries, importing the data set, handling of missing data, handling of categorical data, splitting the data set into training and testing data set, and feature scaling like that. So importing the required libraries. So I am importing these libraries here. So this is actually IRIS dataset. As I mentioned, it is a very good dataset and it is not having any missing values. So I won't be able to show you the missing data handling and all. But this is one library which is used for missing data handling, which is called the simple imputes, sklearn.impute. And from that I'm importing simple imputer. So later on, if you are working with a data set which is having missing values, you can see how you can use simple imputer for that. Then there is a pre-processing from sklearn pre-processing. I am using label encoder, and I am importing label encoder and one hot encoder. And then there is train test split. This is another functionality which will be used for splitting the train and test data set into train set and test set like that. Then there is another thing called the standard scaler, which is used for feature scaling. This is actually, it is used for standardization of the data. Then this is called missing number, like another library. From that I am importing MSN node. So this is used for visualization of missing data. Unfortunately, that is not possible with IRIS dataset, but still we'll just see how it is like that. So importing of dataset we have already done. So that is step is finished. So now handling of missing data. So this, as I mentioned here, this MSNO is used for visualization of the data. So you can visualize the data using this simple command msno.matrix iris_df. So we can see whether it is having any missing values like that. Then we can use other commands also, like iris_df is null. So is null means any null values are there, like any missing values are there or not, it will check. That is the command for that. So we can get the how many missing values are there also using this command .sum. Is null dot sum. So this iris_df dot is null will give the missing values, and .sum means you will get a summary of that, or how many are there like that. So in this case that doesn't work, but because there is no missing value. So you can see this one is giving any missing value? No, it is telling false. So this is the one. And is null dot sum, it is telling all zeros. So there is no missing value in any of these things, like all the features and the target all are having all values there. So there is no missing value. And this is the this is for the visualization. So this is the visualization. So you can see it is fully colored rows or columns are there. Suppose if I was having so many missing values, it will draw white lines here like this. You can see my mouse pointer. So here it will draw a line. Another place here it is, if it is some missing values there, it will draw a line. Like suppose it will be some data sets will have a column in which lot many missing values will be there. Suppose there are 100 values, out of which 70 will be missing. So those things will be very easily, you can identify using this matrix. So it will have lot of white patches like that. So that is, this is one simple thing used for visualization. So now just a mention about how you can handle missing values. So if there are only, suppose for an example, like this IRIS data set is having 150 samples. So out of which totally only 10 data points are missing, 10 missing values are only there. Then maybe I don't have a problem. I can just drop those missing value rows. So I can just ignore those rows or remove those rows from the data set and use the rest of the data set, make the model and get the classification done. But if there are out of 150 data points, suppose 60 values are missing, 60 missing values are there, then I can't do that removal of those rows and making the model, because I'm losing so much of information. My model may not be good enough. Like it is made from a very less amount of data, it is an unreliable model will be formed. So that is a thing which you have to see depending upon the data set provided to you, whether it is having missing values. Yes. Yes. Anything? Anything is there, or shall I continue? Okay.
Hello? Hello?
Yeah, some disturbance is there. Everybody is telling anything? Or?
1 minute, ma'am. 1 minute, ma'am.
Yeah.
Yeah, what I can do, ma'am? They want to ask the question middle of the speech, no? That's why I'm giving a permission to everyone participant is possible to unmute, but they misusing. That's all, ma'am.
Okay. I think
Fine.
maybe I will finish this data pre-processing part, then maybe I will take some 1 or 2. Otherwise, I think time may go. I won't be able to finish the main aspect of these things, no? So I'll take the
Ma'am, one of Shalu, she's asking query regarding TensorFlow.
Okay, I think TensorFlow will be covered tomorrow only. I think TensorFlow is for tomorrow session. I'm only doing with the classical machine learning models only.
And also confusion matrix, right, ma'am?
Yeah, confusion matrix, yeah.
Okay, ma'am.
Yeah. This is the so first thing you have to see with how the data set is there. If it has to be few values, you can drop it. And suppose one column there, it happens that sometimes some columns will have so many missing values, like out of 100 values, 70 are missing. So in that case, you can take a call and you can just drop that column alone, like that attribute alone you can remove from the data set, because it will not give any value addition to the data set. And generally, many of the classical models you cannot form the model. It will give error in case of missing values are there. So before you make the model, you have to fix the missing values. That's why this is important. So if there are floating values like in this case, how the values, sepal length, all that are floating point values. And in that case, any missing values there, you can replace them with mean of the value. Like that is one strategy used. Another strategy is used is to use interpolation. Interpolation like bilinear or cubic interpolation, and you can just fill the missing values. And in case of categorical values, what is done is use the most frequent value. Suppose if it is one category is occurring many times, like it is occurring 50 times, and the other category is occurring only 20 times, you will fill the missing values with the frequently occurring, that same 50 times occurring category, you will fill the value. And integer values are there means, again, you can either use mean or mode depending upon the data set, or maybe some understanding of the feature, what feature it is, like that. So that is also another point, like what type of feature it is, that understanding. But generally, many of the data set, that information about what attribute it is, it will be a confidential information. You may not know what kind of attribute it is. So that if you know you have some understanding about the attribute, you can use that information keep in your mind for filling the values. Now for handling the categorical data. So categorical data will be like, suppose for example, genders. Gender will be male and female, like that it will come. Or some other data will be like hot, cold, or something like that. So, or summer, winter, some options like that will be given in the categorical data. So how you cannot, your model will not take any string values or any those type of, it only can understand numbers. It can't understand anything beyond numbers. That is the machine learning model. So now what you can do is you can encode them using some encoders which is available with the scikit-learn. So that is different types of encoders are there: ordinal encoder, one-hot encoding, binary encoding, and frequency encoding. So if you come to ordinal encoding, you know there are in categorical features, there are features called ordinal features and nominal features. You know, ordinal feature means it will have inbuilt some kind of a order, like if you check the dress sizes, it will be small, medium, large, extra large, like that, or something. See, if here one example is given, see, short, very short, normal, tall. So seeing this data set, values, these attribute values, you can very well understand that it has an inherent order. It is it can't be like tall, short, tall, normal. Means it can't go in another order like that. We can, from understanding of the word itself, we'll understand it has to follow in the order very short, normal, tall, like that. So now when you, for ordinal data, you can use ordinal encoding. So it will give a numbering like that: 1, 2, 3, and 4. So this is the ordinal encoding. So this is, we can be happily using that. There is no problem with this one. But there are some cases when we are not using having ordered data, like nominal. Another one is called nominal data. That is like just a place name, Bangalore, Delhi, something like that, or some other data, summer, winter, or something which we cannot give us particular order. So that type of data means, again, this type of ordinal encoding is not a good idea. So another encoding which can be used in that case is called one-hot encoding. So this is another data you can see the example fire, water, bug, all these things. So this is not having an order. So you can give it is one hot encoding means in the whatever values given, only one bit will be on, all other will be off. So in case of fire, only the second bit is on. And in case of water, only the last bit is on. In case of bug, only this bit is on. So this will be the one hot encoding. But this is advantage in the sense that it is not giving any priority or any extra numbering or like 1, 2, 3, 4 and all these things here. So it will give a equal weightage to all the categories. But the disadvantage is that it will add so many extra features, extra attribute columns to your data set. Suppose you have like 10 type of categorical attributes in your data set. Once you convert all of them with the one hot encoding, you may add up to some 20 extra columns in your data set. So you had 100 extra attributes and you add 20 extra. So 120 attributes it will become. So that is the disadvantage. It will become difficult to handle. So another one is binary encoding. So you will just take whatever this 1, 2, 3, like you will use the suppose 5 categories are there, means you can use a 3-bit representation, like how the binary digits are there. 0 means 0, 0, 0, 0, 0, 1, 2, like that you can represent. So this will not add those many columns. Up to like 15 categories are there, you only need to add 4 digits like that. That is one advantage. And then this is called frequency encoding. So frequency encoding, what is that? It will use the frequency of occurrence or the probability of the case. So whatever is the frequency of occurrence of these things, like fire is occurring 3 times or whatever bug is occurring 2 times. So all these things it will count, and accordingly it will give the probability as the encoded value. But the disadvantage is that suppose if some 2 things are having same number of occurrence, then all that will get the same value. So here also it is shown like that. So that is one main disadvantage, that is with the frequency encoding. So in our case, actually there is no categorical data. This actually I showed for the understanding. So only the target or the classes are in the categorical form, like setosa, versicolor and virginica. So only that I have to change. So this is an example. I am using label encoder and I am changing it. So now you can see it has changed. Earlier it was like this. So now if you see, it became 0 and 1, 2 like that. Earlier it was having all these names, setosa, virginica, like that. Now it became 0, 1, 2. So now coming to splitting of the data. So when you have a training data, means whatever data set you are having, what you have to do with a machine learning model is that you have to split it into test and train set. Advantage is that you don't want your model to see the test set before only during you want it to see the test set only during the time of evaluation, not before that. If it is able to understand the test set beforehand, it will be learning from that, and you will get a very good accuracy. But in case of when you feed the real values or unknown data is given to it, it will perform very badly. That is the main disadvantage, and that's why we do the train test split. So you will take 80% of the data and train the model and test using the 20% of data. So that is how you tackle the situation. So that's why this functionality is there. And another concept is there, overfitting and underfitting. So that is like if you train with the entire data, when you train with the data, model can sometimes overfit. Like you make the model so complex that it will overfit. You can just see this figure and make out. So these are the points. The model is so complex and it is so high dimensional that it is able to very correctly follow the training data set. But when you give the test data set, it will not perform nicely. That is the overfitting condition. And this is the very complex model condition. Another one is called underfit. So this is the underfit condition. So here this is having these points, but we are just fitting a linear classifier here. So this is a underfit, we can call it, and it is a very, very simple model, and it will not, this also will not give good classification. Even overfit also don't give, underfit also don't give. We have to get the right fit. That is why we use many data like what is that feature engineering to get a good model like that. So this is for splitting the data. But first what I am doing is I am just dropping the target from the data set. So from the data frame, I'm dropping the target. So now X will have only these 4 things, only 4 attributes: sepal length, sepal width, petal length, and petal width. So these are the 4 attributes. Now we use the train test split. This is the function which we imported. So this we can use, and I am keeping the 20% as the test set and remaining as the training set, and I am splitting it. So that is how this function is enough for splitting it. Now coming to feature scaling. So feature scaling is like, generally machine learning models are, especially the classical machine learning models, it is very, very much biased towards the numbers. Like whatever numbers you are giving for the attributes are how big it is, it will affect. So generally, if the attributes are very, very big, what will happen is that it will give some weightage for those attributes compared to the small value. Suppose in a data set, one feature is having value 0.1 and same feature is having some values which is 10s, 20s, 30s. It will give more weightage for the values which are in the range of 10, 20, 30s, like that, because 0.1 is very small. That is how the machine learning models are work. So what we have to do is, we don't want to give any weightage for any data. So what we have to do, either we should normalize the data. Original data will be like this, but we want to normalize and we want to make it between 0 and 1. Or if suppose we are very sure that the data is somewhat of a Gaussian distributed data, we can do the standardization and make it a standard normal distribution like this. So these two things are very commonly used. So normalized data can be between 0 to 1 or -1 to 1, whichever way you want. And standardized data means it will be 0 means unit variance data. So that will occur like this. And yeah, so this here I have written some theoretic aspects of that. You can read later. So what all type of Python is using many scalars for that. One is min-max scalar, standard scalar, max app scalar, robust scalar, quantile transformer scalar, power transformer scalar. All these things are available. But very commonly used scalar is min-max scalar. So this is the scalar which will put the values between 0 and 1. So you will have to actually it is very easy to use. You will have to just import min-max scalar and use it. Otherwise, if you go and implement using your own code, you will have to follow this formula and implement. And standard scalar is making your distribution standard normal distribution x minus mu divided by sigma. So this is how. So I am using here the standard scalar. So I can import the standard scalar and I can fit the data with the standard scalar. So I will first fit the data with the standard scalar. So extrain, so even in this case, when you do the standard scaling operation, you should never give the scalar also, standard scalar also to initially see the test data set. So first you will do the scaling fit with the trained data set, and then you will transform with the whatever scaling variables you got, like mu and sigma you might have got. Same mu and sigma you will use for the test data set also. You will not calculate it separately for the test data set, assuming that the test data set comes from the same distribution like that. So that is, so now we finished this one. So some time back, ma'am asked about PCA. So I will just quickly cover PCA. So PCA is a dimensionality reduction technique. It is very good and very useful also. So PCA is follows some standard steps. One is standardization of data. So standardization we have seen, this is called standardization. Then we have to find the covariance matrix of the data points, and then calculate the eigenvalues and eigenvectors. And we should sort the eigenvectors as per the eigenvalues in the decreasing order. Then choose first k eigenvectors that will be the new k dimensions, and transform the original n-dimensional data into k dimension. That is how PCA works. So generally the data will be in such a way that it will be like suppose the data may be occupying a different axis, but we will be following a standard XY axis like that. So if we can change the diamond from the XY axis to a new axis or new what is that like from one we are mapping the data from a one space to another space. If we can, if it is suppose 10-dimensional data, we can map from 10 dimension to 3 dimension without losing much information. That is what is done in PCA. So very crisply we can tell that we can map it from a high dimensional space to a low dimensional space. So that for that, what technique we are using is, we are using the eigenvalues. So first we have to get the covariance matrix. So covariance matrix will capture all the couplings between the data, how the x and y all are all points will have x and y coordinate, like in both directions it may have data present. It will not be like orthogonal directions like that. So it will all be coupled data. So from that covariance matrix that will be captured. And especially PCA is again problematic with the usual data. So the standardization of the data before starting of PCA is very important. That is, this step cannot be skipped. It is a part of the algorithm. And then you can just get the covariance matrix and compute the eigenvalues and eigenvectors. So eigenvalues, eigenvectors will give you the new directions of the data, in which maximum variance of the data is there. So you are getting instead of 10 dimensions, suppose 10-dimensional data, earlier 10 dimension, you are getting 10 new dimension in which the variability of data is maximum. And depending upon the value of eigen, means the range of eigenvalue, the magnitude of eigenvalue, the it will be capturing more and more information. Higher the eigenvalue, it is capturing more information. So that's why we are arranging it in the decreasing order, and we are capturing those dimensions which is capturing maximum data. And then we select those eigenvalues, and then we get those and other eigenvectors we are replacing with 0, and now we will project it to those new dimensions. So that is the thing. So it can be very easily done with whatever Python libraries we are having. So you have to see this is the one which you have to import. Sklearn decomposition, import PCA. So this is the one which is used for PCA. So after that, again, this is all you have seen. So you are getting X and Y, and again I'm doing the standard scaling operation. This operation is very important. It is a step of PCA. So now I am instead of 4 dimensions were there, I am selecting only 2 dimensions. So now PCA with the 2 dimensions I will get. So now principal components I'm getting in 2 directions. So first I'm doing the fit transform, and now I am getting those values and getting and saving in this new data frame. So I am making a new data frame and saving this. These are the principal components which I got by using this simple command pca.fit transform, and I am saving those in this one. So these are the only 2 are there now. Dimensionality has reduced. So earlier it was 4, now it is 2. Only 2 are there. And this is the final. Finally, we can add the final target also, and we can plot. So when we plot that, see now this is the scatter plot of that. So this is not with the usual features. This is the x-axis, it is principal component 1. Y-axis, it is principal component 2. So this is the how the data appears. So you can see I have reduced the dimensionality from 4 to 2. Yeah. So yes.
Madam, when you are executing,
sorry, I can't hear. Your voice is
output
breaking.
that is the target to be retained or not, madam? Executing period should be retained or it should be removed without assessment.
No, when you compute principal components, your target, you are not using the target for that. No, you have to remove the target. Only the this one you should use. X,
Madam,
like these
in
features.
finally, if we take hello.
Yes, sir. You can tell me. Your voice is little breaking, sir.
Madam, it's very cloudy. That's why. Yeah. And after getting PCA, that the eigenvalues and associated eigenvectors, if we combine the outputs, will it be relevant output gets mapped, or will there be any mismatch?
No, it will be very good. Actually, some little bit loss of information will be there, but that will be very less. In this case, data features are less. Only 4 features are there, so I can reduce it to 2 or 3 like that. But in other cases, when there are so many features are there, you can reduce it to, suppose from 10 features, you can reduce it to 2 or 3 features. You will see that you can compare, you can make the machine learning models and see, you will get a model very much comparable with the original data set also, because it will be capturing the data. Even this is a very well-known technique. It is even used with images also, even with some very few, like 1 or 2 principal components itself, because it captures the entire data. So with 1 or 2 principal components, we can reconstruct the image itself. Like it can give a compression, and you can decompress it with and get the high quality image with that. So that type of even in tabular data, it will be able to capture the essence of the data with those 2 components itself. So that is it is very useful. Even just for visualization purpose also you can use. So that is how you can see the this is whatever scatter plot I showed you here. It is no different from the original scatter plot. It is almost something similar to that. You can see the setosa is very much separable, and the other 2 are mixed like that. So that is the case.
Thank you. Thank you, ma'am.
Yeah, so now we will quickly see this model and training. So first I will just, before going to this, I'll introduce the concept of confusion matrix. So yeah, one more thing I want to tell that many places I have given the references like this I have given. So you can further go to these web pages and get a better understanding, even get what is that code, you can try all that you can do. So you the references are also given. So now for confusion matrix, there are some concepts which you have to understand. One is called true positive. So this is so positive, one data set is having, suppose you take a case of a binary data set. So binary data set will have two classes. One is 0 class and 1 class. So 1 is the positive class and 0 is the negative class, like that. So in this example, this dog is the positive class and the cat is the negative class. So you have a classifier and you are giving a for testing a dog picture to it, and it is classifying it as 1. So this is a true positive. You are giving positive, it is output is also classified also as positive, it is true positive. This is the one concept. Second one is false positive. You are giving a cat picture. So this is actual class is 0, but it is classifying it as 1. So this is a false positive. So this is yeah, now true negative. So cat is the class, input given as cat, and it is classifying as cat. So this is true negative. So it is classifier is working properly and it gave the correct classification. Then it comes the false negative. So here the actual class is positive class 1, but it is classified as negative class 0. So this is a false negative case. So this is so for confusion matrix, these four things are very necessary to understand. Whenever what is positive, true negative, false positive, and false negative, like that. So it is explained in terms of a binary classifier, like that. So confusion matrix. What is confusion matrix? A confusion matrix is a summary of prediction results on a classification problem. The number of correct and incorrect predictions are summarized with count values and broken down by each class. This is the key to confusion matrix. Confusion matrix shows the ways in which your classifier model is confused when it makes predictions. It gives you insight not only into errors being made by your classifier, but more importantly, the types of errors that are being made. It is this breakdown that overcomes the limitation of using classification accuracy. So generally one misconception is there that classification accuracy is a good metric for understanding your classifier. That is not the case. Classification accuracy is nothing because the case in which your model is in your data set is perfect. IRIS data set, as I mentioned, is a very good data set. It is a balanced data set. So there you can use classification accuracy as a measure. But there are cases which is called imbalanced data set. Only you will have 5% of the data belonging to positive class. 95% data is negative class. So real life problems are like that. Like if you see what is that breast cancer data set, or something like fraud detection, like credit card fraud detection, you will have 95% of data will be negative class, no fraud. Only 5% data will be the positive class, which is fraud. So those type of things are very common. So you if you use a classifier which is on an imbalanced data set, and it is giving, it can give 95% accuracy, but when you see the confusion matrix, you will understand that not even a single sample it is classifying as positive class, because only 5% is there. It is ignoring all that. It is not giving any importance to the positive class. Only with the negative class it has learned, and it is giving the classification like that. So that those type of complexity is possible with the machine learning model. So that is how these this confusion matrix and these concepts are coming. So this is how a confusion matrix looks. This is the true positive, false positive, false negative, true negative. Like this, it will be put in 4 boxes. So even these two things, diagonal elements will be the correct classification. These things can be even like here false positive can come, here false negative can come. That can happen. And this false negative is called type 2 error and false positive is called type 1 error. So like performance matrices are many, but as I told you, accuracy is not a good measure. There is another thing called precision and recall. These are very good and very widely used in case of imbalanced data set. So accuracy is can be computed like this. This is true positive plus true negative divided by this diagonal is the correct classification divided by the entire data set. The all 4 boxes, you will get the accuracy value. So you can see this total predictions, you will get the this entire. But this precision is a very precision and recall. These two things, one thing also is not sufficient. Precision and recall together, it is a very good measure. So this is a little bit of difficult concept. It is like when you tell the precision, you will only look from the point of view of the classified values from the model, whatever it classifies. So see, this is the data which is used for telling the precision. You are only seeing the predicted values which is predicted as positive. In that, how many are correct, like that. So that is percentage of your results which are relevant. So it is giving 8 as positive prediction it gave, out of which 6 are only relevant. So 6 by 8 is the precision here. That is how it is calculated. True positive by true positive plus false positive. And recall, it is also called sensitivity or true positive rate, is the percentage of total relevant results correctly classified by the algorithm. Now, earlier we saw from the point of view of predicted values. Now we will see the point of view from the actual values. From actual values, how many classified correctly? So actual values, actually it is only 7 are there. So out of it, 6 it is correctly classified. So that is how recall is given. And F1 score is the what is that? The harmonic mean of these two things, recall and precision. So generally, many of the machine learning models, like they use precision, recall, and F1 score as the metrics for seeing how good it is, like that. So these are some more theoretical aspects which maybe you can just read later. So I will just very quickly show you the models and the confusion matrix. So for modeling and training, I'm importing all these libraries. So I'm just showing with decision tree classifier. Actually, I have given examples with the logistic regression, SVM, and MLP classifier also. And we have to import this functionality called metrics for getting confusion matrix and all these false positive, true positive, and all these things. So we can plot the confusion matrix with this function, plot confusion matrix. And if we have to see precision, recall, F1 score, this function we should use. And then classification report, it will give a very good what is that, small matrix kind, everything together in a this one. And then actually k-fold, this is for cross validation. I could not cover this one. And this is confusion matrix in actual confusion matrix. This is for plotting. So decision tree classifier. So decision tree classifier, you might have seen the theory of it. So now coming to the classifier, you are classifier is can be with both the criteria. One, it can be entropy or Gini index. And there are so many options. We can give maximum depth, minimum samples per split, minimum samples per leaf, minimum weight fraction per leaf, and maximum features. All these type of many things are there. You can change all these things and see also. So first step is, once we have done all the data pre-processing, we have to split it. And after splitting it, for the classifier, we have to take the classifier and then train the classifier. This is the classifier. I am getting it as DT_score CLF, and first I am giving the condition as entropy. Criterion is entropy and information gain is the criterion for the split. And now I am fitting it with X train and Y train. So now after fitting with it, my classifier is ready. So it now after training, it is ready to be ready to use, and we can predict the value with that. So prediction I am making with the test set. So here I did the split. Now I have the X test also available. So I am using this X test for predicting, and I have the actual classes for that. This is the actual values, real values for the X test. That is also available. So now if I run this, I'm getting some good accuracy, like 97.36% I am getting for this. And for this tree classifier, there are some extra functionalities we have. We can plot the tree. See, this is the actual tree, how the classification happens. So it is taking all these rules into account, like it should be like, see here in the first step itself, it is able to, like how I told, Setosa is linearly separable. It is able to classify it and separate it. Actually, other two classes, it has grown the tree till here to classify it as versicolor and virginica. Orange is Setosa, green is versicolor, and this purple is virginica. So just because these two are not linearly separable, the tree is grown up to this one to separate these two things. Actually, we can even use these options. How much depth should be there, maximum depth, how much split, like minimum samples for splitting, and all these things we can change, and we can see how we can get a very good model. Because sometimes this kind of a overgrown tree could be a overfit also, that it is possible. And we can even print the rules, whatever rules used in the decision tree, using these commands. Export underscore text DT_CLF. We can give the feature names and get the tree rules printed. This is all just for the understanding purpose. So now we come to the confusion matrix. So now, yes. Okay, sorry, this import cell I didn't execute, so it was not having the library. So now I imported that. So yeah, so now you can see the confusion matrix. Actually, this is not a binary classification case. It is having three classes: Setosa, versicolor, and virginica. So that is why these three are there. Otherwise, it will have only like this 4 boxes. So this is having 9 boxes. So it is having a very good accuracy and all. It is only one misclassification is there. Yeah, we can print the classification report. You can see whatever is given in this matrix, this one, actual values like F1 score, precision, recall. for each category, like all classes, Setosa, versicolor, and Virginica, you can see them separately. And accuracy, all these things you can see. And extra one thing which this tree classifiers gives us something called the feature important. You can give this command and get the feature importance from the feature. So it will be this is the decreasing order it has given the feature importance. So petal width is the most important feature. Even petal length is another important feature. After that, these two are having very less feature importance, sepal width and sepal length. Even when later on you can make the model with these two features alone and see that it is performing good like that. So that is one good thing we can see with the tree type of classifiers. It gives the feature importance. So here I am just showing the feature importance. So first one is the most important. Then second one, these two are like very tiny bars. It is not very important. So since time is not there, I am not showing this logistic regression and all. It is all same, this one only it goes. So this alone I will just quickly tell. This is MLP classifier. So MLP classifier is called, it is multi-layer perceptron classifier. It is a neural network classifier. So it is a little bit different from the normal classical machine learning kind of classifier. So MLP classifier will, you might have seen the neural network structure. It will have many neurons like input layer, hidden layer, and output layer like that. So that type of a structure MLP classifier will have. So many neurons will have. First step here also you have to divide into test and train. And MLP classifier, you can give the number of neurons you need in the hidden layers. So I am giving it as 10, 3, 10, 10, 5 like that. And then there is activation function. So it uses a non-linearity function. So that I am selecting as ReLU function. We can use any other. Some more non-linearity functions are there like sigmoid, tanh, and all that. So we can select which is appropriate. And then we have to mention the number of iterations it has to iterate. And then again, this is the very normal step. First fit the classifier and then predict. These two steps are always followed in the same method. So first fit using the MLP classifier, then predict the test set. So it is this is giving a full 100% accuracy like that. So if we change all these values again, it may change. Like if I made the hidden neuron 8 in number, so it changed to 95%. All these things happens. So again, this is the confusion matrix. And this is the classification report. So I think I think mostly everything I covered, only logistic regression and SVM classifier I didn't show, but it also follows the same methodology. But first you have to fit using X train and Y train, and then classify by sending the X text test, and that is the method. Then after that you have to get the confusion matrix, etc. So I think now with this I will finish. I would like to thank everyone for your patient listening, and I really hope it was useful to you. Anybody is having any? Actually, I think I took around 20 minutes extra, so you can you are having any quick questions you can ask.
Ma'am, they asking to send a code and material. You please share your PPT and then codes also, ma'am.
Yeah, this Jupyter notebook which I was demonstrating, I will send you the same thing. You can share it with them.
Okay.
Yeah. So
anyone they have any queries, you please free to ask the question to madam. Hello.
Yeah, yeah. Hello,
Hello,
yes.
ma'am.
Yes, hi.
Yeah, ma'am, I have one question. You talked about, a lot of these methods of encoding, like missing, and not just I'm not talking about missing values. I'm talking about encoding methods.
Yeah.
Yeah. So, like one hot encoder, binary encoder, and then frequency encoder also. We
Yes,
talked
yes.
about advantages and disadvantages of them, but I'm just a little confused about which one would be the best one to choose.
Yeah, actually that depends upon your data set. We can't tell like that. Suppose very easily I can tell that if it is having a order like suppose the values are like small, medium, large, then you can use label encoder because it will give them values like 1, 2, 3 like that. So it is that there is a number weightage comes for that, but that is there inherent in that categorical data also. But in other cases, if it is some are like very evidently like male and female, you can use one hot or some 0 and 1 will be used. But there are some cases where you can't say which is the best like that. Then in that case, what you have to do is you will have to do a little bit of trial and error. First you try with frequency encoding. Then there are other encoders also like which is called like robust encoding, which I didn't go into details. Then there is target encoding, which use the target information or the class information also for encoding like that. So those type of things we can try, like with the model, we can try and see which works better like that, which gives a better accuracy or the precision recall like that, because
Okay.
we can't have a hard and fast rule for that. And especially if we have some kind of information about this data, like this attribute is this kind of a thing, then maybe you can put that also into the thought process for selecting that. But if the data is very much like only what is that attribute 1, attribute 2, you don't have any idea about what is that, then you can't do that type of thing. You will have to work out only, like you will have to apply with the label encoding. Then maybe one hot encoding may work because it is not having any disadvantages like that. Means it don't give any weightage for the values, but the disadvantage
Maybe
is
for
that,
small features, maybe
yeah,
for a data set with small features, one hot encoder will be
yeah,
fine.
that also is possible. If suppose one category is having 10 values, there you can't use one hot encoding. Maybe there you may be forced to use label encoding or maybe frequency encoding. But maybe one category is having only 3 values, like in our target case, only 3 values. So that type of one attribute is having only 3 values. So it will only add 3 more extra features to the, so there you can use. So those type of what is that trade-offs and all, you will have to do and fix it.
Work out, right, ma'am? Okay, ma'am. Thank you so much, ma'am.
Yeah, thank you. So I'm stop sharing the screen. Is it okay? No?
Yeah, ma'am, please share your notes and PPT presentation and codes also, ma'am.
Yeah, sure. Yeah.
Hello, ma'am.
Yeah.
Ma'am, if you are working with a balanced data set, then accuracy is a better measure, right?
Yeah. Actually, if it is a balanced data set, accuracy is a very good measure. But whenever it is not a balanced data set, then you will not be able to make out anything from the accuracy. Like one example I told, if it is a very imbalanced data set and positive class is only 5%, you can't make out from accuracy. There, it will not give you anything. So that's why there precision recall and F1 score. F1 score is like a balance between precision and accuracy. Like F1 score will tell you that both the things together, what is there like that. So F1 score will be generally used, not precision, accuracy, precision and recall separately also. F1 score will give you, because there is a trade-off between precision and accuracy. As precision increases, precision and recall. Precision increases, recall will reduce. Recall increases, precision will reduce. So F1 score will give you the what is that fix of these two things. So F1 score, like it is the harmonic mean of both the things, so that you will use it.
Yeah, for unbalanced data set, we can go for precision, recall, and F1 score.
Yeah,
Right, ma'am?
F1 score is good. This one. Then there are some others also, like
Hello?
some other metrics also you can use, but F1 score is very good measure.
Ma'am, what about specificity calculation? Specificity.
Actually,
Is it suitable for balanced or unbalanced cluster?
Yeah, the specificity is actually specificity is same as precision. No, it is something like precision only. It is not different. Precision is called this is called sensitivity. Recall is called is having one more name, TPR, true positive rate, and sensitivity. And I think this is precision is having one more name. I think it is specificity.
Hello, ma'am.
Yes.
Hello, ma'am.
Yes, I
Madam,
can hear. Yes, Srikanth.
what is significance of, yes, madam, what is significance of random state? What is the random state mean?
Yeah,
Or what?
actually, random state. We have to suppose you are selecting these what is that train and test by train by test, like that. You want to split the data, or any thing you want to have the data. You have to like shuffle the data. You have to get the data not like as per the order. Initially, have you observed the entire data was like it was in order, like first 50 was Setosa, and then versicolor, like that. It was in order 0 0 0 1 1 1, then 2 2 2, like that. It was not a shuffled data set. You can't in machine learning models, if you have to make it robust, you will have to give it in not in the order like that. You will have to shuffle and give them, so that it will, otherwise I think whatever order you give, it will all take into its learning, like it is in some order, so it will learn that order also in while learning. So maybe when later on it is not in order, it will not give you a good what is that classification. So generally we tell, no, it is like human beings, we are able to generalize very well, like that. What we see, what we understand, what we learn, from that we are able to generalize, and when some new thing comes, we will be able to do it in a better way, like that. So same way, we want our model to be robust in such a way that once a new this one comes, new data comes, it should be able to classify it properly. That's why we do it in like we want to make it robust, so we won't give it in any order. We will make it shuffle, and in random order it has to take, like that.
Thank you, madam. Thank you, madam.
Yeah.
Excellent presentation.
Thank you. So yeah.
Anybody have queries? No. Well, thank you very much, Indu ma'am. Yeah. Please proceed, ma'am.
Ma'am, you said precision and specificity both are same, right?
I think
the specificity is true negative divided by true negative plus false positive ways, but precision is true positive divided by true positive plus false positive.
I think it is 1 minus specificity. 1 minus specificity, I think. No, 1 minus.
Okay, ma'am.
Yeah.
Can you differentiate both things, ma'am, specificity and precision, in terms of the performance analysis?
Actually, specificity, this is 1 second. That is one is true This is recall is true positive rate. Correct?
Yeah,
Yeah.
recall is sensitivity, ma'am.
Yeah, sensitivity. So specificity is like I think it is 1 minus precision. It is 1 minus.
Okay, ma'am.
Yeah, it is mainly I think you have to understand precision and recall from the point of view of how it is used. Like this is the understanding you have to get. Like when you are telling precision, you are telling it from the predicted values alone. It is possible that your model is predicting only one value. Suppose this true positive is 1 and here it is 0. You are getting a precision like precision of 1. Your model is very good like that. But when it comes to recall, it might have out of 10 actual positives, it only given one correct prediction. Their recall has gone to 0.1. So there, that is where the balance is there. Like precision is very high, recall is very low. So it is not a good model. So when you can, if you can improve it, we can improve it. Otherwise, we will be able to see it in F1 score when we take the harmonic mean of these two things, that it is not a good measure like that.
Okay, ma'am. Thank you, ma'am. Thank you so much.
Okay, then, ma'am, we'll close.
Thank you very much, Indu, ma'am. So, yeah. Anybody have a, yeah. Anybody? Hello? Hello?
Yeah, I think no more questions, I feel. Yeah, so we can.
Thank you, ma'am. Indu, ma'am, you explained very nicely, very informatively, how for one command, how is possible to visible different types of plots, and also you explain eigenvalues, eigenvectors. Actually, this is comes under linear algebra, and also they're using SPD where you explain principal value. Principal component analysis. Actually, that is application of linear algebra. You explained how they calculate using statistics method, and also that is the one part you explained, but same principal component is possible to find out by using singular value decomposition also.
Yes.
Yeah, you explained very nicely, and also shown that how you execute the thing. Theory part is separate, but how we execute, how we get that, these things are explained very nicely. And also you explained what you assign, everything you explained very nicely. Plotting, accurate, especially for confusion matrix. Totally that once you study for that, totally you become a confused for that matrix. That is they treated as confusion matrix, because I already attended confusion matrix in R. That's why I know. Finally, we confuse with that matrix. Taking the values. And also you explain the things for visualization part, data processing also, they explain very nicely. Some, especially some participants, they ask to need to know that part. You explain very nicely, ma'am. I don't have a word to say. That's the way you explained. Thank you very much once again. We are expecting same cooperation from your side in further future also. We are once again thank you from our BIT side and also from our friends means participant sides also. You have fulfilled everything, ma'am, what we have assigned for you. Thank you very much once again, ma'am. Please share your PPT and also.
Thank you, ma'am. Thank you very much for your nice words, and thank you all for your patient listening. Thank you.
Yeah, that your talk is good. That's why even though 5 o'clock, nobody's not ready to go.
Okay.
That's why. Thank you.
Yeah, thank you.
Thank you. And please share your PPT and also a code. Rahisha, she told, madam is told in the morning she's going to share, but still she's not at share. Please.
Okay.
I don't have your mobile number, no. That's why I can't contact through mobile, please.
No.
Otherwise, the participant, they're going to start after 7 o'clock, madam, PPT presentation, code, everything.
Yeah, sure, ma'am. I'll send it.
Okay, thank you very much once again, ma'am.
Thank you.
Bye. See you and take care. Yeah.